So in this lesson here, I'm not going to have a bell work as I usually do. I kind of want to go straight into the lesson. So today we're going to be learning something called graphing systems of linear inequalities. So inequalities are those, sometimes in elementary schools, they're described as like mouths, but then greater than and less than sign. Sometimes they're also the greater than or equal or less than equal sign as well. But you have definitely learned this lesson in Algebra 2 if you've taken it. If you were in my class last year, you've definitely have seen this slide before because I used the same slide that I taught my Algebra 2 students with my Algebra 3 student. So this lesson should feel very much review. So let's get into it. It says the first step to graphing a system of equation is to solve for y. So the first thing you want to do is to solve for y because you want to get it in that y equals mx plus b format, or in other words, that slope-intercept format. So that way you can easily graph the line onto the coordinate system. The second thing you want to do is when you graph the equation, here's the thing. If you want to graph a solid line, it needs to have the inequality with the equal sign underneath or that line underneath. So anytime you see a greater than or less than equal sign, then you can use a solid line. You use a dash line when it doesn't have the equal sign. So either greater than or less than. And you do need a shade. So you're going to graph the line and shade depending on which way does the inequality face. Basically, if y is greater than, so if y is greater than, let's say, x, so if y is bigger, you always want to shade above. When y is less than the equation, or x, you want to shade below. And I'll explain why when we're graphing. And then what you want to do is when you graph your lines, you want to look for those intersections. So basically, where does all the colors meet up if you're graphing more than one equation? So we're going to start off by graphing just one equation, and then we'll graph like two. Okay, so in this slide, you can see I just have one equation for each problem that we're going to graph, but I did put them in standard form. So we have to first solve for y before we can graph. That's the first step to graphing inequalities. So we're going to first solve for that y. So the first problem here, I need to move this x over if I want to get y by itself. So I'm going to subtract x to both sides. So that would cancel, and then y would drop down. So y is less than 2 minus x. So now I can see that my slope here looks like it's negative 1 over 1. And my y-intercept, or my b, is 2, right? So that tells me, okay, well, if I want to graph this line here, I can use my y-intercept, which is at 2, so it'd be right here. So let me plot that. And then my slope here says negative 1 over 1. So I have to go down 1 over to the right 1 and then plot. Now, based off of this inequality here that has an equal sign, this is going to be a solid line based off of that inequality. Okay, so in that case, I'm going to connect the dots using a solid line. And now I have to do some shading here. So when I'm shading, I need to think about which way is the inequality facing. Notice how it says it's facing away from the y value, right? So that means that y is less than this equation. If y is less than, think about all the y values that are really small, or in this case, really negative, right? So all the small y values are down here. So when y is less than 2, you want to shade below, like as if you were heading to the negative y values, which would be down here. So I'm going to shade below this line. And that's it. So here is the representation for this inequality equation. This one here, also in standard form, I need to get the y by itself, so I'm going to start there. So in this case, maybe subtract the 4x first. I'm going to do that. That would cancel. negative y comes down, inequality comes down, and this will be 4 minus 4x. Then from there, I have a negative in front of this y, so I have to divide by a negative sign. So I'm going to do that here. I have to divide it to every term. So then y comes down, but we learned a long time ago, I think it has to be like middle school. Anytime you divide by a negative sign, you have to switch the inequality, so it goes this way instead. And then this would become a negative 4 and a positive 4x. 4 divided by negative 1 is negative 4. Two negatives make a positive, so that becomes a positive 4x. So looking at this before I graph, it seems like my slope is 4 over 1, right? Because that 4 is in front of x, so 4 over 1. My y-intercept is negative 4, since that's my constant. So let's go to the y-intercept for at negative here. So negative 4 is my y-intercept, but the slope says up 4 over 1. So I'm going to go up 4, up 4, which would be right here, and then over 1, which would be right here. And then I'm going to plot my line. This time it looks like I need a dash line. That looks like a dash since there's no equal sign. So I'm going to dash my line here. And then I'm going to do some shading. So when I shade, I need to look at which way does this inequality face. So it says that y here is bigger because it's facing towards the y. So if y is bigger, I want to get all the big y values. And all the big y values are heading towards positive infinity up this way, right? So that means I want to shade above this line. So I am shading towards that infinity as y goes up. So I want to shade above this line. So basically I want to shade in this section and not in this section, or else I'd be going downwards towards the negative y value, which is not what we want if y is greater. All right, so now that we've gotten warmed up here, let's do it where we have to graph two equations on one coordinate system. Okay, so in this one here, I have my first equation. This time I'm going to label it by color so that way you know which one I'm referring to. So I'll do the first one in green, and as you can see here, this equation is x plus y is less than 1. So first, it's in standard form, so I'm going to have to, first write it as slope-intercept form to get the y by itself. So it looks like I need to subtract this x off, so I'm going to do that first. So if I subtract x, this would cancel, and then y, I'll just write it up here, would be less than 1 minus x. So this is now my equation. Let me write it right next to it. That bothers me. That's so up in the air. So this is y less than or equal to 1 minus x. So in this case, my slope here is negative 1 over 1, and my y-intercept is just 1, right? Because that slope there would be a 1. That would be my y-intercept. So I'm going to plot this line here at 1 for my y-intercept, and then I have to go for my slope down 1 over 1. And then when I connect the dots, it looks like I'm going to be needing a dash. Oh, not a dash line, a solid line. So I'm going to graph a solid line here. So here's my solid line, and now I'm going to do some shading. Now when I shade, it does say y is less than this equation. So when it's less than, you want to shade below the line, because y is smaller, so notice that I'm shading in the region where y is less than this line. Now for this one here, notice how it's just x is greater than 1, so it's x is greater than some number. Well, in this case, because it's just one variable, x, this is already solved for us. When x is equal to 1, it's right here on the x-axis, right? And you might remember this from one of the previous lessons, but when you have an x equation, this is what we call a vertical line. So we're going to draw a vertical line, and it needs to be a solid line because this inequality has an equal sign. So I'm going to draw a vertical line that's solid, and there we go. And then once I draw that, I do need to still shade. And so shading, notice how x is greater than 1. Well, if x is greater than 1, all the x's on this right-hand side of x are greater than 1. So I want to shade in this region because these are the x values that are bigger than 1. I would not want to shade this other half of the region because that's where x are less than 1. Notice how they're going to negative values, so I wouldn't want that. Now, what I'm going to be looking for is where does the two color intersect? And as you can see, they intersect right here, kind of like forming a triangle. So I'm just going to kind of box in that area right there, but that's where they are intersecting. So I'm going to be looking at where are the colors or the shaded regions for the two equations intersecting. So let's try it out with this one here. Again, it's in standard form, so I'm going to have to move some stuff over first. So this is my first equation. I'm going to have to subtract the 2x over, so that would cancel. And then I would have negative y is greater than 2 minus 2x. And then I still have to divide by a negative to get rid of that negative off the y. So I'm going to divide everything on the other side by a negative to cancel. But when I divide by a negative, remember to switch the sign. So then this becomes negative 2 plus 2x. Since negative 2 divided by negative 1 gives me a positive, and so 2 divided by 1 is a 2, so 2x. So here's my final equation that I'm going to be graphing here. And in this case, it looks like my slope here is 2, so 2 over 1, and my b, or my y-intercept, is negative 2. So when I plot this, I need to be at negative 2 on the y-axis, and then for my slope, I have to go up 2 over 1, so right about there. And this needs a solid line, looks like it, since of the equal sign. So here's my line. And when I shade, I do need a shade, looks like I need a shade below the line because this says y is less than this equation. So below the line would be down here, right? Since these are the y values that are really negative. So I want to shade below this line where I'm heading towards the negative y values. All right, so now for my second equation, I have a y equals or is less, y is less than 4. So because y is by itself, this is a special type of line. This is a horizontal line. So anytime y is by itself, you have a horizontal line. And it's going to be plotted at 4 when y is 4. And then I'm going to draw a horizontal line, but it needs to be a dashed line based off of this inequality since it has no equal sign. So I make a dashed line here, and it's horizontal, as you can see, very flat. Since a horizontal line, because it's really flat, the slope here is also 0, by the way. Just thought you'd, quick tip there. So the slope here would be 0 if it's a flat line like that. So now I need a shade. So when I shade, y is less than 4. If y is less than 4, I want to be shading below this line because these are all the numbers that are less than 4, right? So I'm going to shade below. And I'm looking and seeing where do the colors intersect, and they seem to be intersecting right here. So that is where the two functions meet. So this is where they're intersecting, and that's it. So I wanted to show you the shading method because when you're going to see it on your test, obviously, but you're also going to see in your project if you decide to go after those bonus points. So you can get bonus points if you color in your graphs, and this is one way you can do it is using inequality signs like these. But you have to figure out which way to shade based off like which way to face the inequality based off which way you want to shade. So like I said, if you want to add color to your project's graph, that's just for bonus points. But I thought I'd show this lesson here to help you guys get an idea. All right, that's it for this video.